Hi, Kyle Forrest here, Region Field Technical Consultant for the South Central. I'm closing out my day, and before I completely shut down, I want to take a few minutes to talk about heat pumps. Whether it's people that have called in today, maybe with some misexpectations of product, or as I'm seeing posts on social media of, hey, it's cold outside, you should turn off the heat pump, and immediately go to electric heat, it's not going to keep up. It's not always true. I'm not going to argue a heat pump is going to lose capacity as it gets colder outside. Heat pumps do not make cold air. Heat pumps absorb heat from outside and reject it into the living space. Because of this, as it's colder outside, there's less heat for the system to absorb, the harder it has to work. This is where I always encourage anybody selling heat pumps or working with heat pumps, especially the Linux product, take some time to go on Linux Pros and let's look at what the systems can actually do. So one system I've got pulled up here, I've went and matched one of our Merit systems to one of the Signature air handlers. It's not common that you would do this, but there's some benefits to that Signature product that I want to talk about at the end of this video. So where I bring this up on this match of the single stage heat pump, got a lot of calls on this one today on people saying the systems aren't keeping up and they're swapping on emergency heat just to find out that even the heat strips have less capacity than the heat pump itself. It would have been better if they hadn't turned on emergency heat. So where I bring this up is when we look at heat pumps and how they're sized. In the Houston market, they should be sized for 47 degrees of outdoor temperature because that's our average outdoor. That 47 degrees of outdoor temperature is going to be right at about 22,500 BTU. So when it's 47 degrees outside, that heat pump system is going to have about 22,500 BTU. So on this conversation, that's going to be expressed just under 2 tons of capacity, right at 1.875. So on this though, what about right now? As I'm filming this video, it's 25 degrees outside. At 25 degrees of outdoor temperature, that's actually closer to 16,400 BTU, or 1.37 tons. This is where I've had some people today, hey, the heat pumps weren't keeping up, we swapped it over to emergency heat, and the systems just aren't performing. Well, how'd you size your heat kit? If we look at this here, one of the calls I got today on the 2 ton was a technician calling me with a 5 kW heat kit, and he's telling me it's not keeping up. Well, that 5 kW at 240 volts is only 17,000 BTU. At the time when he called me, it was actually closer to about 35 outside. That single stage heat pump's closer to 18,600 BTU. He actually lost capacity putting it in emergency heat mode. Not much, but it was less than what the heat pump would do. So on this conversation, this is where I see guys have some mistakes made when selecting heat pumps. I get we're in a design for 47, but sometimes we have to consider the worst case scenarios. Like last night, we actually dipped down to 10 degrees for a little bit. At 10 degrees, that single stage heat pump's only good for about 12,700 BTU, almost half its nominal capacity. We're talking about 12,000 BTU per ton. This unit got about half of its 100% rated capacity. This is where when we talk about heat pumps, I wish we'd have more conversations about low ambient. This is one of our entry-level low ambient units. Of the 3 tiers of product, this is the cheapest one. The EL18K SLV, the new side discharge low ambient machine, if we look at it at 47 degrees of outdoor temperature or design condition, it's right at 24,000 BTU. The 2 ton unit's actually 2 tons. Take the same machine, and again, it's 25 degrees outside right now. That's closer to 21,500 BTU on this match. That 21,500 BTU, when we look at this, that's going to be a lot better performing machine. That's 1.79 tons right there at even 25. And what's funny is the low ambient units, as we actually drop in temperature, they're going to pick up performance. When it gets cooler outside, we can run these compressors harder. We can increase compressor speed, so you'll see that represented in wattage, as wattage almost doubles over 5 degrees of difference. But look what happens to capacity, it comes back. This new side discharge, even when it's 10 degrees outside, it's 23,500 BTU. When we look at that in capacity, that's 1.96 tons. For the single stage unit to have that capacity, you would have to have it 55 degrees outside. And this new side discharge is doing it at 10. So again, this is when we go back to some of the heat kit sizing, where I have people calling in with 5 kWs, and if we actually look at not just manual J, your heat loss, heat gain, but your manual S, your system selection and sizing, might have been better if they went to an 8 kW. So on that 8 kW at 240 volts, they're going to be closer to 27,300 BTU. So I'm not going to argue here that electric heat is going to have more capacity across all ranges in the heat pump. But what are you giving up for that? This 8 kW heat kit, that's your wattage. You're gonna have to run 8,000 watts to get 27,000 BTU if your house is at 240 volts. We go back and we look at this heat pump system at our design condition of 47. It's gonna give you 24,000 BTU, only 3,000 BTU less, or a quarter of a ton, and it's doing it while the compressor is consuming just over 1,500 watts. At 1,500 watts, that is most of the electric heaters that you're gonna buy at your local Lowe's or Home Depot. Yes, that same 1,500 watts. Watts is watts, no matter if it's 120 volts or 240 volts. That has the same heat consumption. That is obviously a lot less than 8,000 watts. It's astronomical. This is kind of one of those where I know a lot of people, they immediately just want to say, well, a gas furnace can't be beat. And I'm not going to argue with that. Yeah, a gas furnace on the same match, if I was putting it in as a 2-ton, I would probably select a variable speed unit like this one here, even a single stage product, and its minimum capacity it's ever going to have is 36,000 BTU. So of course a unit with another ton of capacity is going to have a higher temperature rise, but at what cost? This is where I worked on this Excel spreadsheet today and tried to do some comparison. I looked at a load. Funny enough, this is actually the trailer, Mel. And on the trailer, looking at it and trying to rate everything of its insulation values. Of, hey, if that demand BTU on that's 23,500 BTU when it's 47 degrees outside, that trailer would have to run for 200 hours a month. So if I just heated it with electric heat and I paid 15 cents per kilowatt, 8 kW heat kit's gonna give me 27,000 BTU, and because my actual output capacity is higher than my load, I would have to run for 172 hours, not my 200. But on this, just the electric strips themselves would cost me $206. That's just the electric elements themselves to run that electric heat kit for 172 hours. So what if I just put in a single stage heat pump, an entry-level option here? That entry-level option at 47 degrees is going to be somewhere around 24,600 BTU if I change the indoor unit. If I go to a little bit smaller coil, I can actually pick up some capacity. So maybe sizing it with a CBK 45 instead of the 48. But I have a reason on the 48 again, we'll circle around to. That compressor is going to run at 1.34 kilowatts or 1,340 watts. With the extra capacity, we can run for 191 hours in the month, and it'll cost me $38.40 just to spin the compressor. If it was 35 degrees outside, of course capacity is going to start to fall. Wattage is going to fall a little bit. We're taking some working capacity off the product. Now because the BTU is lower, the compressor has to run longer, and it's going to cost about $50 a month to run it. At 5 degrees outside, we're definitely losing some capacity in the product. To gain 12,000-ish BTU or just under a ton, we're running the compressor at 1,100 watts. It's going to run longer, but our utility cost doesn't change that much. This is where we get into a comfort factor, and we could actually put in the new side discharge. At 47 degrees, it's a true 2-ton unit. It's 24,000 BTU. Compressor's just over 1,500 watts. It's 196 run hours. It would cost $45.53 to spin that compressor for 196 hours at 15 cents a kilowatt. At 35 degrees, capacity does fall a little bit, so runtime comes up. And as that runtime comes up, so does the utility cost. Now saying this, as we drift down to maybe 5 degrees, we're down to 22,600 BTU from the 24,000 nominal. And yes, that compressor is going to run for 390 hours in the month, but we're going to do it at $189. We're not too far off our utility cost here between 206 and 189, but again, this is at 5 degrees, that's at 47. This is our comparison of 47, a 45.53 compared to 206. So in our average condition for the Houston market, do you want to run your system at $45.53 of heating load, the compressor, or the electric heating elements? This is where I have to say, if you have a gas furnace and it's natural gas, you're never going to beat forced air natural gas. Forced air natural gas, we take that 45,000 BTU furnace, and again, that 45,000 BTU furnace, since it's 80% efficient, gives you 36,000 BTU of output on capacity. That output on capacity will get us here. It's going to run for 131 hours. More capacity than our demand, less runtime, 131 hours. We pay for natural gas and therm, 75 cents per therm. You burn through 5,875 cubic feet of gas. It's going to cost you $44.06 to burn natural gas to heat your house. If it's propane, this is the most expensive way you can heat your home. Take the same furnace but change your fuel cost. Propane right now is $3.60 a gallon. To run this furnace for 131 hours, you're going to burn through over 64 gallons of propane. That's going to cost you $231 a month in propane. It's the most expensive way to heat your home. So this is the conversation. If you're on natural gas, I don't see a cost benefit of going to a heat pump. There can be some comfort stuff with zoning, but I will give up a little bit of comfort to not heat my house for $231 a month. Again, this is at 47 degrees of outdoor temperature. This is at 47 degrees of outdoor temperature. What would you want your utility costs to be that month? Depending on your down payment, that could actually be the note for your HVAC product. So, the big shining factor between all these is going to be comfort. That heat pump unit at 24,000 BTU, moving 800 CFM, and living at sea level, you're going to have a temperature rise somewhere around 28 degrees when the system is set up properly. If it's that single stage unit and as capacity falls, like we were showing that single stage at 35 degrees, somewhere around 1.5 tons of capacity, yes, you're going to have some discomfort here. Your heat pump will never be as comfortable as that gas furnace off temperature rise. Normal heating temperature rise, human comfort, you're typically going to see about 40 degree temperature rise for target. So when we get to 5 to 10 degrees outside on a single stage heat pump, there's a lot left on the table. This is where you take that 45,000 BTU furnace, even 80%, it's 36,000 BTU output, you move 800 CFM, you live at sea level, and yeah, your temperature rises over 40 degrees, your comfort's there. But this is where I shout back to that CBK48 and something that's often overlooked. As long as your outdoor unit is wired non-communicating, the CBK48 has the option called even heat. There's a sensor connection on the board where you'd add an 88K38 or 21891, those are discharge air temperature sensors, and then you have the option to have a target even heat. If it's a non-communicating control, your even heat option would be here. Even though you'd wire the outdoor unit non-communicating, if you had a communicating thermostat, the setting would be in the S40 display. As long as you have the discharge air temperature sensor, you could have a target supply air plenum temperature. So on this conversation, you could potentially stage that single stage heat pump even when it's 10 degrees outside with a properly sized heat kit and have more capacity than the gas furnace. That 39,000 BTU at 800 CFM at sea level is a 45 degree temperature rise. Now, you don't have to go all the way to the CBK48 to get this comfort. There are options to do it in other product, even the entry level stuff such as the CBK45 or Merit air handler to match with the Merit unit. It would be called balance point control. You can still do balance point control with fully communicating and variable capacity, just can't do even heat. But even not having a unit that's capable of wiring a discharge air temperature sensor, balance point control is the option of, hey, it's factory set at 50 degrees. Anytime you're above 50 degrees, only be heat pump. We showed the act capacity calculator. Above 50 degrees, the single stage heat pump will absolutely maintain. Then you have a low balance point. Hey, the factory low balance point is 25. You could be a little bit more aggressive with that. Why not run the heat pump? Just because it doesn't have a lot of capacity, the utility cost we showed is fractional compared to just the electric heat. Why don't we run the heat pump with the electric heat? Low balance point is anytime we're below low balance point, we're only going to be emergency heat. Anytime you're between your low balance point and your high balance point, it'd be both. So what if we had a high balance point for 50 and a low balance point for, say, 0? Anytime that we can't maintain temperature, let's let it run both. Let's let it run electric heat and the heat pump. It's not going to be the most cost effective, but it's going to be the most comfort. It's going to have more capacity than just running the emergency heat kit. So this is just some things to consider. I'm a big fan of even heat and having target discharge air with a heat pump, but a bare minimum, you can set up balance point control with a Linux thermostat. Just some things to think about and go over as we talk about heat pumps and maybe not just throwing them to emergency heat because it's cold outside. Dive into the data, see what it can do, reach out to your local field technical consultant, and let's go over this further. If you have any questions, don't hesitate to reach out. Thank you and have a good day.